Now let's look at the fourth rule, which is the chain rule. The chain rule is important, so we're going to spend a little bit more time on it. So in the chain rule, you will see two functions and they are interlinked. So the function of u, so y equals to the function of u, and u equals to the function of x. So I'm going to write it in different colors because the gx is going to look a little bit confusing. I hope this looks slightly better. Okay, so let's imagine this chain here. So I have y being a function of u, and I have u being a function of x. So we'll look at an example to make sense of this, but let's look at the chain rule first. The chain rule states that dy over dx is equals to dy over du times du over dx. dy du came from y equals to function of u, and du dx came from y equals function of x. So basically, we are getting the differentiated function of u multiplying by the differentiated function of x. Let's look at the example. So in this example, we have y equals to x squared plus 1 in bracket to the power of 15. So let's look for our function of u first, then our function of x. So as you can see, in this bracket, we have x squared plus 1. So this will be our function of x. So let y equals to u to the power of 15. This will be a function of u. And then, because y is equals to u to the power of 15, our u is equals to x squared plus 1. So this is a function of x. So when we differentiate y equals to u to the power of 15, we will get our dy over du. When we differentiate our u equals to x squared plus 1, we will get du over dx. So let's use the chain rule now. Chain rule states that dy over dx is equals to dy over du, which is this one here, times du over dx, which is this one here. Okay, so to differentiate y equals u to the power of 15, I'll bring down my power 15, u remains, and my power minus 1, which is 15u to the power of 14. I'll write it down here first. To differentiate u equals to x squared plus 1, I will have to use the sum rule. So differentiating x squared first, I will get 2x plus 1 is nothing. So du over dx is 2x. So now I have 15 multiplied by u to the power of 14 times 2x. I have two unknowns, but I know that u is equals to x squared plus 1. So I'm going to replace it. Now I can simplify everything. So 15 times 2x will give me 30x. X squared plus 1 to the power of 14. This will be my final answer. So now let's look at this question. Y equals to 2 over 6x squared plus 5. This question, bear in mind, is different from the one we saw earlier, which is y equals to 9x squared plus 1 over x. When we have 9x squared plus 1 over x, they share a common denominator, which allows them to be split up using the same denominator. Okay, with 9x squared in one fraction and 1 in the other fraction. However, for this question here, they don't share a common denominator, and there is no numerator for you to split up. is just a single 2. So then we'll have to change this form. So I'm going to change it this way. 2, 6x squared plus 5 to the power of negative 1. Okay, why negative 1? Because 6x squared plus 5 was in the denominator. So to bring it up, the power, which is 1, will become negative. So now I have a form that allows me to use the chain rule. So now I have to find my function of u and my function of x. So I'm going to see this as my function of x. So let y equals to 2u to the power negative 1, and my u will be 6x squared plus 5. So using the chain rule, dy over dx is equals to dy over du times du over dx. So if we see here, when we differentiate dy over du, you'll use the constant multiple rule. So the constant stays, and now we use the power rule. We bring down the power, u, and the power minus 1 will give you negative 2. So to differentiate the function of x and u, I'll have to use the sum rule. So to differentiate 6x squared, I'll have 6, bring down the power, x to the power of 1, plus 5 will be nothing. So my dy over du will be negative 2u to the power negative 2 times du over dx is equals to 12x. So I'm going to replace my u with 6x squared plus 5 from above to the power negative 2 times 12x. So my final answer will be minus 2 times 12, which is negative 24x, 6x squared plus 5 to the power negative 2. We will make this prettier so that we don't have negative powers in our final answer. So our final answer should be negative 24x over 6x squared plus 5 to the power of positive 2. So this question, we have y equals to in square root x squared plus 2x plus 2. To make it easier to differentiate, I am going to change the square root to a power. So I have x squared plus 2x plus 2, and my power is half. So we are going to identify the function of x now. So this will be the function of x. So my u will be, my y will be y equals to u to the power of half, and my u will be equals to x squared plus 2x plus 2. So I'm going to differentiate these two lines later. Let's look at the chain rule first. dy over dx is equals to dy over du times du over dx. Now let's go back to differentiating the two lines. So dy over du is equals to, using power rule, I bring down my power, u, and my new power becomes half minus 1. So it will be half u to the power of negative half, which will be half 1 over square root u. What happened here is, since it is a negative power, I'm going to put it down into the denominator, and since half is square root, my u becomes a square root u. Okay, so my dy over du is 1 over 2 square root u. Now moving on to find my du over dx. Du over dx is simpler. I will just have to use the sum rule. So differentiate x squared first, I'll get 2x. Differentiate 2x, I'll be left with 2. And when I differentiate 2, I'll just get nothing. So my du over dx is 2x plus 2. I'm going to put in bracket here first to avoid confusion with this multiple sign. Okay, so now I need to put in my x's into the u. So I replace the u with this. X squared plus 2x plus 2 multiplied by 2x plus 2. I'll put them together, factorize 2 out because I can cancel it out later. So I cancel these 2. My final answer will be x plus 1 over the square root x squared plus 2x plus 2. Alright, so let me give you a shortcut using the chain rule. So we see here y equals to a function of x, and in this function of x there is a power, and in this case the power is half. So dy dx, this is the chain rule shortcut, alright? So we'll bring the power down, the function remains, the new power of the function minus 1 will be the original function minus 1, and then the differentiated function. So in other words, you see the power half, the original function, which is x squared plus 2x plus 2, the new power, which is minus half, and then the differentiated function, which we will see 2x plus 2 differentiated from here. Alright, so to simplify all this, we will have 2x plus 2 on top over 2 square root x squared plus 2x plus 2. So what happened here is my 2x plus 2 went up in the numerator. This 2 in the denominator stay below. X squared plus 2x plus 2 went below because it is a negative power. And then I'll factorize my 2 out on top. Cancel out my 2, and my final answer will be x plus 1 over x squared plus 2x plus 2.